All right, number 8, we want you to understand how to read a matrix. So we are given a matrix that is already in reduced row echelon form. So that means it is completely solved. Okay, and we want to use the variables x and y, and we're going to determine if the system is consistent or inconsistent, and if it is consistent, give a solution. So what does this mean? Consistent means we get an answer. That means we find an answer. Inconsistent means we don't get an answer. There's no solution. If you see ones down the diagonal and zeros everywhere else, means we get a consistent solution. So let's talk about again how to read this. What this means, remember x and y, we always go in alphabetical order, x, y. I don't know why I like to separate it. We have 1, 0, 0, 1. And then over here we have, my mouse is covering that up, -3 and 6. Okay, so that means in this column, where that 1 is, that's the x column. X equals -3. Right here in the y column, where that 1 is, telling me y equals 6. So we get an ordered pair, -3, 6. So if I had two systems of equations, they would intersect at this ordered pair. We get one solution. So what does the first row represent? So the first row represents x equals -3. X equals -3. All right, what does the second row represent? This right here. So my y in that column, y equals 6. Y equals 6. And then do we get a solution? So is it consistent or not for the third part? So it says it's inconsistent, but that's not the case because we get x and y value. So the system is consistent and the solution is this ordered pair here. So it tells you type an ordered pair. So we're going to type -3, 6. Okay, so number 9, we want to solve this using matrix row operations. And then if it has no solutions, we're going to say that it's inconsistent. So I'm going to show you the whole process, how we do reduced row echelon form by hand. I'm going to do some mental math, but you'll be able to replay this and write it down and see what's going on. So I'm going to start out writing the augmented matrix. So I'm going to have 1, 1, and then -8. And then over here I will have 1, -1, and then 6. Okay, so first I want to get a 0 in everywhere below here. So in order to do that, I just need to multiply by -1 and then add those. So the first operation, we're going to do row 2. I'm going to change that up. It equals -1 times row 1 plus row 2. Okay, so that's my first thing. So when I do that, row 1 is not going to change, so it's still going to be 1, 1, -8. All right, but I'm going to do this math. I'm going to tell you what I'm doing. I'm going to do it mentally. Multiply by -1 is -1, and you add 1, we get a 0. Multiply by -1, and then add this -1, we get a -2. Multiply by -1, we get a +8. Add this, we get 14. Okay, so this is first step. This is a 0. Now we need this row to be a +1 because we need ones down the diagonal. So how do I make this become a +1? We can just multiply this row. So we're going to say row 2, I'm going to change row 2 again. Row 2 is going to be equal to row 2 divided by -2, because I'm only trying to get that one. So I'm going to multiply that one or divide by -2, and that will become a +1. So I'm going to do that now. So I get a 1, 1, -8. Row 1 is still not changing. Here, when I divide by -2, 0 divided by -2, still 0. -2 divided by -2 is 1. And 14 divided by -2 will give me a -7. Okay, so I got 1s down the diagonal, but I also want to make this change. I want this to be a 0. So the way I can make this a 0 is by multiplying this, now that they're the same, by -1 and adding those. So the next row operation would be row 1, which is changing, and it is going to become -1 times row 2 plus row 1. So row 1 is going to become a -1 times this and add it to this. Okay. So this time row 2 is not changing, but row 1 is. So this is my last operation. So 0, 1, and then -7. That is not changing. So if I multiply by -1, 0 times -1 is 0, and then when I add 1, this is still 1, and then I multiply this, -1 times this is -1 plus this would give me a 0, and then -1 times a -7 is a +7. +7 plus a -8 will give me a -1. So here is our final solution. This means x equals -1 and y equals -7. This is the process that you have to go through all the way for every row, every column, to make sure you get reduced row echelon form and solve it. Now, calculator can do this as well. I want to show you that. It's going to do it all at once for us. So I'm going to go turn this on. I'm going to clear this out so I get a clear window. A lot of steps, okay? So watch this video as many times as you need to get all those steps. First, we have to go second matrix. We're going to go over to edit. We're going to go to every one of these. We're going to all at one at a time. So I'm going to go over to edit. I'm going to go arrow back. I'm going to edit this one. I want a 2-row, 3-column matrix. So 2 by 3. I'm going to insert my original. So 1, 1, -8, 1, -1, and 6. Okay, so double check. 1, 1, -8, 1, -1, 6. When you get that entered, second quit, the mode button, second mode to quit. All right, so we have the matrix in. So now we're going to go second matrix again. This time we're going to the middle for math. We're going to arrow up all the way to REF, which stands for reduced row echelon form. Basically means we're going to solve this matrix for you. So it's saying reduce row echelon form. What do you want me to solve? We got to go back to second matrix one more time, second matrix, and we're going to call the one that we want to solve the one that we just edited, which is A, or just option number 1, and then we hit enter. Okay. And you see at the very bottom it has done all of this work that I did by hand in a matter of seconds if you can just enter it. So x is -1 and y is -7. So -1 and -7.